moon. So take it away, Dan.
Thanks very much, Greg. Can you hear me, Greg?
Yeah, hear you loud and clear. And you can...
Okay, fine. Let's see, I'm trying to start my webcam. I keep pressing... Oh, here we go. I think that'll work. Let's see, I need to allow that. There we go. Can you see me now? Okay, excellent. Well, I want to start out by thanking... It's wonderful to be here at the Lunar Science Forum. I want to start out by thanking the organizing team for putting together such a marvelous forum done in this way. I'm Dan Lester from the University of Texas. I wanted to tell you today about putting telepresence on the moon, which is something that I doubt if many of you have thought about very much, but in the context of the future of human exploration of the moon, I think it's a very important thing to consider. Now, let me try to go on to the next slide here. Okay. I want to take a step back and talk about human cognition, because that's kind of what it's all about. We can put our human cognition far away in different places, giving us a sense of presence in those distant places. We can use our cell phone, we can use Skype, we can put our audio and our vision in different places. We do that electronically now. You know, that capability was once only achievable by putting human bodies at the place where you wanted to be. And the electronic strategy we do now is called telepresence. Let me digress for just a moment. It's a real pleasure to be giving this talk to you by telepresence. And I want to be very clear about one thing, though. Although my physical presence with you can be said to be virtual, this talk isn't virtual. This talk is real. It's as real as if I were standing in front of you. You can see me, you can hear me. So please don't forget that. Doing tasks by telepresence is not about doing them virtually. It's about really doing them, though doing them remotely. Now, we can go on and we can talk about what I call the cognitive mandate for space exploration. Depends on really two things. It's the control latency, the time delays, and the bandwidth, the amount of data you get back. So let's talk about that a bit. I do want to back up just a second and say that the idea of space telepresence was considered in some detail by a symposium I co-organized last year at Goddard. Many of you were probably there, the Exploration Telerobotics Symposium. And what this symposium was all about was telepresence as a new paradigm for human-robotic cooperation, a new way of thinking about that relationship between humans and robots. And all the presentations that were given there and the final report that was put together are available on that website that's listed there. So, okay, what does it take to have quality telepresence? Let's put together a recipe for telepresence. What kind of control bandwidth do you need? Bandwidth is dominated by human vision. And vision is, it's about 10 megabits per second per eye. You want to put a number to that. If you want haptics, if you want dexterity, for some reason you might want audio, that's going to add a little bit, but not very much. And with modern compression technologies, which are really pretty amazing, and let's say some generosity, let's say you can get away with 1 megabit per second. 1 megabit per second is what you need for telepresence. How about control latency? Those of you who do online gaming would realize that when you get latencies that are larger than 50 milliseconds or so, or 100 milliseconds, you're going to start getting shot through the chest, and your head's going to get chopped off and stuff like that. But I think the better number to use is the human reaction time for visual stimulus, which is the time it takes for something from my eyes to go into my brain and down to my hands and make that happen. That number is about 1/5 of a second, 200 milliseconds. And that's an interesting number, because what that does is it defines what I call a cognitive horizon. You multiply that number by the speed of light, and you divide it by 2 because you want the cognition to be two-way, and you come up with a number of 30,000 kilometers. And that's a really interesting number. That means that if you're closer to your exploration site than 30,000 kilometers, you can have really high-quality telepresence there. The trouble is, everywhere we want to go is way past that. The Earth to the Moon latency is 2.5 seconds. Earth to Mars is tens of minutes. And so the bottom line is we can't have quality telepresence at these locations from the Earth. You just can't do it. Ways involving human spaceflight. How can we best put telepresence on the moon? I think what's important is to think about where you're controlling it from. Let's suppose you have people in low lunar orbit controlling telerobots down on the surface. Latency is really small, milliseconds on that scale. The low lunar orbit is a hard place to be. Your sites that you want to explore are rapidly rising in setting. The orbits are mostly unstable. But there are ways to do better. We can go to Earth Moon L1 or L2. And those are kind of neat places. They're about 60,000 kilometers or 400 milliseconds two-way latency from the lunar surface. It's not quite real time, but it's close. And what's more, if you're at L1, you have line of sight to the near side 24/7. If you're on L2, you have a line of sight to the far side 24/7. Earth, Moon, L1, and L2 really gives you a cognitive connection. It gives a cognitive connection between the human brain and the lunar surface. And you know, being closer than that doesn't necessarily help a lot if you're doing it telerobotically. Okay, so suppose we had a habitat at Earth, Moon, L1, or L2. Wouldn't that be an enabling site for control of lunar telepresence? These are a factor of 6 less than the Earth. You have nearly real-time operations, continuous access to the near or far side, unlike low lunar orbit. Your line of sight back to the Earth is stable. It's just over your shoulder if you're at L1, unlike low lunar orbit. Very little lunar orbit maintenance is required. We're talking about on the order of tens of meters per second per year, unlike low lunar orbit. And also, sitting up there, you can control telerobots at multiple surface sites. You don't have to just stick to one site. Now, I want to make this point very clear. Having a habitat there does not mean that you don't want to have visits to the lunar surface. We'd love to do that. That would be wonderful. Jim just talked about all the great things we could do if we had people down there. But putting humans into gravity wells, down in gravity wells, is expensive. It's an expensive game. And at least in the near term, we may not have the funds to make it happen. I think another way of looking at it is, as it says right here, the most potent goal of on-orbit telerobotics for the moon, figure out how you might do the same thing for future visits much farther away. And much farther away, the latency penalty is much, much larger. And by putting people, say, in orbit around Mars, controlling things on Mars, you can make a huge difference in your capability. So, habitation facility, Earth, Moon, L1 or L2. You know what? We've actually been talking about that for a long, long time. The concept first came up in the Payne report back in 1986. Decadal planning team was based on this kind of a habitat. That was about 10 years ago. It's been referred to many times. In fact, even in the 2010 NASA authorization bill, L1 and L2 were referred to as notional destinations. And in many respects, these places are linchpins in a deep space transportation architecture. Many of you have heard about the interplanetary superhighway, which makes it really easy, at least propulsion-wise, to go from one Lagrange point to another in the solar system.
One point to another.
Was there a comment? I'll keep going.
We have an open.
What could we use telepresence for on the moon? You know, it's just about everything you'd want humans to do there, and you can go through this list by yourself, but look at it this way. If you had dexterity, and you had ideally haptics, and you had vision, you could manipulate and collect samples, you could do site surveying, you could do all kinds of things, including deploying habitat and support facilities for future human visits. And yes, you could do this all from the Earth, and I think it was referred to, Paul Smoudis and Tony Leroy have this idea in their roadmap, but it would just take a lot longer to do. Let's see. Now, this strategy of on-orbit telerobotics is actually being checked out on ISS, where astronauts sitting up in ISS can control a robot down on the Earth's surface. The way they do it mostly is through TDRS. So their signal goes to TDRS and then back down to the ground station and then finally over to the robot. And that link actually introduces 2 to 5 seconds of latency, although you can do it 24/7. But that 2 to 5 seconds of latency isn't really like the kind of connection you'd have if you were at L1 or L2. Now, what you can do from ISS is you can communicate with that robot directly when you fly overhead with a very low latency. The trouble with that is that the overpass only lasts 7 to 10 minutes. And so you really can't understand the ConOps for that very well that way. Look, here's the picture. Okay, the picture is that on-orbit telepresence is a new way of viewing unit-robot cooperation. There's a habitat at Earth, Moon, L1 or L2, and that funny blue line is a communication link down to the lunar surface, where in the inset you see that communication link going into a hub that has a local area network, that all the little box around it are tied into that local area network. That's one way to do that. I couldn't help in doing this really to think about a link budget. You want a megabit per second. How hard is it to get a megabit per second from the lunar surface up to Earth, Moon, L1 or L2? Earth, Moon, L1 or L2 are not that close to the lunar surface. They're 60,000 kilometers away. And I did this little plot where on the ordinate is what the size of the receiving antenna you need at the habitat, and on the abscissa, the size of the transmitting antenna on, let's say, your rover. And as you can see, depending on your power and depending on the antenna sizes, you can do all sorts of things. The little point right in the middle is an interesting one. That's the MSL X-band with its tiny high-gain antenna. That's a high-gain antenna that's less than a foot in diameter. And if you had that down on the lunar surface, powered by a 20-watt transmitter, it would only take less than a 1-meter diameter antenna on orbit to be able to pick it up. So that's very nice. So what does this on-orbit telerobotics look like? Well, there are lessons that come from terrestrial applications. There are terrestrial telerobotics going on all the time. At the left, you see the guy sitting there in an Air Force base in Virginia piloting a drone over Afghanistan. At the top, there's a guy on a shipboard doing undersea oil, gas, or cable maintenance. On the right is telerobotic mining. This is actually done a lot in Canada and Australia. This might be a guy in Toronto driving a bulldozer in Alberta. Down at the bottom, surgery, where that surgeon can be operating on a patient just off the field of view or else on another continent. We can do this. We understand how to do this stuff. Okay, just quickly, the evolution of space telerobotic control goes all the way from Lunicod and driving Lunicod around the lunar surface to the upper left, the space station, remote workstation, and down in the lower right, that's what we're talking about. We're talking about a habitat where we have astronauts at Earth, Moon, L1 or L2 controlling operations down on the lunar surface. What you're looking at is space telepresence enabled. This is it. Think about what this means. This is really very exciting. On-orbit telerobotics can offer human presence where we never want to send humans. We can put human telepresence on the surface of Venus. We can put human telepresence on a boat on the methane lakes of Titan. We can put human presence in scuba diving under the oceans of Europa. We can do this. And what this means is that thinking about telepresence in this way, there are lots more destinations for human exploration than we ever really thought about before. Okay, so where do we go from here? Just about done. We can think about the HAB. We'd like to build it in such a way that we have control functionality. You'd like an optimal orbit, probably not low lunar orbit, maybe Lagrange points, maybe some Molniya kind of orbit, lots of possibilities. We want to think about telerobotics. What kinds of telerobotic modes do we need for fully immersive telepresence? And thinking about Venus or undersea on Europa, extensibility to other destinations. Things that will work on the moon won't work at those places. I think a really important thing to think about, though, is the policy-specific issue, and that it's sort of encapsulated in those two pictures there. You know, what we've got to do is reconcile historical exploration with on-orbit telepresence. Can you be exploring if you're not all the way there? That is, we know that things on the left, that little picture on the left, look like an explorer, but can the picture on the right look like an explorer as well? So I'll just end here. And I've got my little graphic, the evolution of exploration, which shows that what exploration has come to is really where we can put exploration at a distance telerobotically. Thank you very much.
Great. Thanks so much, Dan. Great talk, and very timely as well. I know Jack Burns and David Kreng, two of our PIs brought on during our NLSI era, have studied this situation quite a bit. Jack and the space station astronauts had their first test of this that I think that you referred to a little bit earlier. They're going to be
right. In fact, that was just a couple of weeks ago with the HET work. Yes.
That's right. And their next one is, I believe, end of next week. So this is really great. So we're running a little bit late here. Actually, I'll just ask this one question here that's from Jack Madden. Could a laser communication system be implemented in these situations?
Well, I think that would be just fabulous. Now, because of course what you want is bandwidth. You want bandwidth at a long distance, and that's exactly what lasercom is for. What that does mean, however, is your rover has to be pointing that laser fairly precisely. It has to be pointing that laser precisely at the habitat, which, of course, if you're at L1 or L2, that habitat is not going overhead very fast. It's moving across the sky very slowly. And so what you might think of is a rover where you tell it to drive from point A to point B, and you don't actually have a human being driving it remotely. Rovers are smart enough these days that they can pretty much drive themselves. But once it gets there, then you can make that connection and start doing dexterous manipulation with hands, with shovels, with drills, things like that.
That's fantastic. Kurt Fisher, I apologize for missing your question. Dan, would you be willing to answer that online via chat? Kurt's question there.
Okay, yes, I will. That's fine. Will do.
Okay, great. Well, thanks again. Really enjoyed